All right, strap yourselves in because we're diving deep today.
Deep, deep.
Into the world of quantum teleportation.
Oh, yeah.
Oh.
That's the good stuff.
You've been
That's what we're here for.
exploring quantum computing and all that jazz.
Absolutely.
And today,
It's wild.
we're going to break down some fascinating new developments.
Oh?
So, we're looking at a video
Right.
that explains some recent breakthroughs by scientists at Oxford University.
I love those guys.
And trust me, this is not just some dusty old research paper.
No.
This is some juicy stuff.
It could change the world.
Yeah, it really could.
As we know it.
Potentially change the world as we know it.
Yeah, and what's really exciting here is that the Oxford team
These guys are rock stars.
has achieved something truly groundbreaking
Okay.
in the field of quantum teleportation.
All right, so we got to back up for a sec.
Yeah.
For people who are like, quantum teleportation.
Yeah, what is that?
That sounds like Star Trek. Right, exactly.
Beam me up, Scotty.
So, to understand why this is such a big deal, we need to start with the basics.
Okay, right.
What is
It?
quantum teleportation?
Yeah. We're
And
glad you asked.
Forget about Star Trek.
Forget it.
It's not about beaming objects.
No, it's not about that.
Okay.
It's about transferring information.
Okay, so we're not talking about teleporting physical objects,
Right.
but information.
But the information,
How does that even work?
how does that work?
I mean, like,
Well, let me tell you.
yeah.
It all comes down to this mind-boggling concept
Okay.
called entanglement.
I've heard of this.
Yeah, you probably have.
Entanglement.
It's one of those things, it's like so weird. It's hard to wrap your head around.
It's like,
It really is. So
yeah,
imagine two particles
Okay.
linked together
Uh-huh.
in such a way that they're essentially
Okay.
two parts of the same whole,
Oh,
no matter how far apart they are.
so they could be
They could be on opposite ends of the universe
on opposite ends of the universe
and still
and still be linked.
be linked.
Wow.
You change one,
Okay.
the other changes instantly.
So if I change
In perfect sync.
one particle over here,
Yeah.
the other one on the other side of the universe
Yeah.
changes at the same time.
At the exact same time.
That is wild.
It's like they're communicating faster
And then
than the speed of light,
the speed of light.
which, as you can imagine,
Yeah.
has really thrown a wrench into our understanding of physics.
Yeah, I can only imagine.
Because one of the fundamental tenets of physics is that nothing can travel faster than light.
Right.
But entanglement
Yeah.
seems to be doing just that.
So it's like having two coins
Okay.
that always flip to the same side,
Okay, I like it.
even if they're miles apart.
That's a good analogy.
Yeah.
Yeah.
That's wild.
Yeah, it's really wild.
But how does this
Well,
connect to what the Oxford scientists actually did?
good question.
Because we're talking about teleportation
Right.
and we're talking about entanglement.
Yeah.
Two particles.
Okay.
So how do those two things connect?
So here's where it gets really interesting.
Okay.
In the past,
Okay.
scientists have been able to teleport
Yeah.
single quantum states,
Okay.
which is kind of like teleporting
Okay.
a single bit of data.
Like a 1 or a 0.
Exactly. Like a 1 or a 0.
Got it.
But the Oxford team
Okay.
went a step further.
Oh.
They successfully teleported
Okay.
a logical quantum gate.
A logical quantum gate.
Yeah.
Now, I'm not a physicist, so break that down for me.
No problem.
What is a
So think of gates
logical quantum gate?
like the building blocks of quantum algorithms,
Okay.
the instructions that tell a quantum computer what to do.
Okay, so instead of
So
teleport
instead of just teleporting
a single bit,
a single bit of
you
information,
teleport it.
they essentially teleported an entire operation.
Oh, yeah.
So it's like
Okay.
they teleported a whole line of code
Yeah, a whole chunk of code
instead of just
for just one letter.
one letter.
Right.
Wow, that's pretty impressive.
That's very impressive.
Yeah.
And the truly groundbreaking part is that they achieved this teleportation
Uh-huh.
between two separate quantum processors.
Okay.
So they had two separate
Two separate quantum computers.
quantum computers, yeah.
Okay.
And they teleported this gate from one to the other.
Okay.
They essentially created a way for these processors to interact and perform operations together
Uh-huh.
as if they were physically connected,
Go.
but without any wires or cables.
So they used quantum teleportation to create
They did.
a sort of wireless connection
A wireless quantum connection.
between two quantum computers.
That's exactly right.
What?
Yeah.
That's incredible.
It's pretty mind-blowing.
What are the implications of that?
Well, for one thing,
It could help us solve one of the biggest challenges facing quantum computing.
Okay, which
The
is basically
scalability.
scalability.
Yeah.
Meaning
Making these things bigger.
making quantum computers bigger.
Yeah.
Okay.
Because current quantum computers are limited in size.
Okay.
Because the more qubits you pack together,
Right.
the more likely they are to experience errors.
Because they get all
It's like trying to build a house of cards
wonky.
on a vibrating table.
Oh, that's a good
It's really hard to do.
analogy, yeah.
Oh, yeah.
So they're really fragile.
They're super fragile.
Yeah.
Yeah.
So are you saying that this teleportation breakthrough
I am saying.
could allow us to build much larger
Much larger.
and more powerful quantum computers
By linking smaller ones together.
by linking smaller ones together?
Yeah.
Oh, that's amazing.
So instead of trying to build one giant,
Yeah.
super fragile quantum computer,
Yeah.
you can build lots of little ones
Uh-huh.
that are more stable
And then connect them together
and then connect them together.
using teleportation.
Using teleportation.
Yeah. That's incredible.
It's like building a supercomputer out of interconnected modules.
Oh, wow.
Each one operating with higher fidelity
Yeah.
because it's smaller and more stable.
Oh, so this opens up
And that
a whole new world of possibilities.
opens up a whole new world of possibilities
Yeah.
for what we can do with quantum computing.
This is starting to sound like something straight out of a science fiction movie.
I know, right?
Yes.
It's amazing how much science fiction is becoming science fact these days.
It really is.
It's an exciting time to be alive.
So how does this all connect to things like a quantum internet?
Okay.
So revolutionizing industries.
Right. So if we can link quantum processors together wirelessly,
Uh-huh.
we can start to imagine a future
Okay.
where quantum computers are networked on a global scale.
Okay, like the internet, but
Like the internet, but
quantum.
quantum. And that's where the idea of a quantum internet comes in.
A quantum internet.
Yeah.
That's pretty crazy to think about.
It is pretty crazy.
Yeah.
Imagine a network
Okay.
where information is transmitted,
Okay.
not as bits,
Uh-huh.
but as qubits, using the principles of entanglement,
Which you talked about earlier.
which we talked about earlier.
Right.
And because of the nature of entanglement,
Yeah.
it would be fundamentally more secure.
What do you mean?
Because any attempt to eavesdrop on the transmission
Okay.
would instantly alter the quantum state.
Like if someone's listening in,
Yeah, if someone's trying to snoop,
they disrupt it.
they disrupt it.
And,
And both the sender and the receiver would know.
oh, wow. So it's like
Well,
having
yeah.
a conversation
Yeah.
where no one could listen in without you immediately knowing.
Exactly.
That's incredible.
It's like having a conversation that's
Yeah.
protected by the laws of physics.
Wow. But how would a quantum internet actually change things in the real world?
Okay, well, think about it.
Okay.
Every industry
Yeah.
relies on information in some way.
Right.
A quantum internet
Okay.
could revolutionize everything,
Okay.
from finance and healthcare
Uh-huh.
to material science
Oh, wow.
and artificial intelligence.
So it could change everything.
It could change everything.
Pretty much?
Yeah, pretty much.
Wow.
Take drug discovery, for example.
Okay.
Imagine being able to simulate the interactions of complex molecules
Okay.
with incredible precision.
Oh, that's pretty cool.
This could lead to the development of new drugs
Oh,
and therapies
that's amazing.
for diseases that are currently incurable.
So we could be talking about a world
We could.
with faster cures,
faster cures,
better treatments,
better treatments,
and maybe even longer lifespans.
potentially. Yeah,
That's amazing.
it's really exciting.
And that's just
And that's just one example.
one example.
Right. A quantum internet could also revolutionize communication,
Okay.
making it virtually unhackable.
Right. We talked about that.
Think about the implications for governments,
Yeah.
financial institutions,
Mm-hmm.
and even individual privacy.
Like, what would that even look like?
I mean, it's hard to say for sure,
Yeah.
but it would be a completely different world
Yeah.
than the one we live in today,
Yeah, no kidding.
where our data is constantly being collected and monitored.
Yeah.
A quantum internet could give us back control
Over our own information.
over our own information.
Wow. This is all incredibly exciting.
It is.
But I'm curious, what are some of the biggest challenges
Oh, there are definitely challenges.
that stand in the way
Yeah.
of making this quantum future a reality?
One of the biggest hurdles
Yeah.
is maintaining quantum coherence.
Quantum coherence. Okay.
Yeah, remember how we talked about qubits, the
Yeah.
building blocks of quantum information?
Yeah.
Yeah, they're extremely fragile.
Oh, right. Like the House of Cards.
Exactly, like the House of Cards.
Yeah.
And they're susceptible to interference from their environment.
So anything can
Even the slightest disturbance
mess them up.
can cause them to lose their quantum properties,
Okay.
which leads to errors in calculations.
So it's kind of like trying to keep a soap bubble from bursting.
Yeah, that's a good analogy.
Yeah.
It's really delicate.
So it's like we've got this amazing potential,
We do.
but it's really hard
It's really hard to control.
to actually harness it.
Yeah.
Because it's so delicate.
Yeah.
So what are we doing about that?
Well, scientists are working on it.
Okay.
They're trying to find ways
Uh-huh.
to make qubits more robust
Okay.
and develop better error correction techniques
Okay.
to protect them from environmental noise.
So like shielding them
Yeah, shielding them.
from outside interference.
Finding ways to correct for errors
Yeah.
that inevitably creep in.
Okay.
It's a tough problem, but people are working on it.
Okay.
And then there's the challenge of scaling up.
right, because the Oxford team
The Oxford team only teleported a gate
only teleported to gate
between a few processors.
a few processors.
Yeah.
But to
To
build
build a truly powerful quantum computer
right.
or a quantum internet,
Yeah.
we need to be able to reliably teleport information
Mm-hmm.
across much larger distances.
So it sounds like there's still
There's still a lot of work to be done.
a lot of work to be done.
Yeah.
But is there reason?
Oh, absolutely.
Right.
Optimistic.
There's tons of reason to be
And
optimistic.
about the future of quantum technology.
Yeah, I mean, this Oxford research
Yeah.
is just one piece of a much larger puzzle.
Oh, really?
Researchers around the world
Okay.
are making incredible strides in quantum computing.
So it's not just
Global effort.
Oxford, it's
Yeah, it's a global effort.
everybody.
People are working on this all over the world.
That's pretty cool.
Yeah.
Yeah, from developing new types of qubits
Uh-huh.
to exploring different approaches to quantum communication.
Okay.
It's a really exciting time to be in this field.
Yeah, it sounds like it.
There's so much happening.
So we've covered a lot of ground
We have.
in this first part of our
Yeah.
deep dive.
Yeah, we have.
We've talked about quantum teleportation,
Right.
the groundbreaking research at Oxford,
Those guys are amazing.
and the potential of a quantum internet
It's mind-blowing.
to transform industries and change the world as we know it.
It really is.
We've also touched on some of the challenges
Right.
that lie ahead,
Yeah.
like maintaining quantum coherence
That's a big one.
and scaling up this technology.
Yeah, it's another big one.
But before we move on,
Sure.
I want to make sure I'm understanding
Okay.
the key takeaway here.
All right.
Is it that this Oxford breakthrough
Yeah.
is a significant step
It is
towards making large-scale,
large-scale,
practical quantum computing
practical quantum computing.
a reality?
A reality.
I got it.
That's exactly it.
And that's why
And that's why this research is causing such a stir
Mhm.
in the scientific community.
People are freaking out.
People are freaking out.
It's a major leap forward
Yeah.
with the potential to unlock a whole new era
A whole new era.
of technological advancement.
It's really exciting.
Okay.
Yeah.
So we've laid the groundwork.
Yeah.
We've got the basics down.
The basics are there.
Now, in the next part of our deep dive,
yeah.
I'm really curious
I am too.
to explore some of the more philosophical questions
Oh, the philosophical questions are the best.
raised by this research.
Yeah.
If quantum technology has the potential
Right.
to change the world so dramatically,
Which it does.
what are the implications
Yeah, what does it mean for us?
for society,
For society?
ethics, and even our understanding of reality itself?
That's the big one.
Right. It really is.
That's the one that keeps me up at night.
Yeah, because
It challenges everything.
it challenges everything we thought we knew
Yeah.
about the world.
We'll dive into those questions and more
I can't wait.
in the next part of our deep dive.
Let's do it.
Stay tuned.
All right. Welcome back.
So before we shift gears
Yeah.
to the more philosophical
Right.
implications of a quantum future,
Yeah.
I do want to take a moment to recap
Sure.
what we've learned so far
Okay.
about this Oxford team's groundbreaking research.
Okay.
Because all this talk about
It's just a lot to take in.
building a quantum internet
Yeah.
and revolutionizing industries
Yeah, it's pretty mind-blowing.
is incredibly exciting.
Yeah.
But I also have to admit
What's that?
that part of me
Okay.
is a little
Right.
uneasy.
Yeah.
I mean,
yeah.
We've all seen those sci-fi movies
Right.
where
Yeah.
technology
Gets out of control.
gets out of control.
Yeah.
And, you know,
It's a common theme. It makes you wonder,
Yeah.
what are some of the potential downsides
Sure.
or challenges we might face
yeah, that's a really important point to consider.
as we enter this quantum era?
Any new technology,
Yeah.
especially one as powerful as quantum computing,
Right.
comes with potential risks
Okay.
as well as benefits.
So what are we talking about here?
Well, one concern is that bad actors
Right.
could use this technology for malicious purposes,
So we're talking about, we're talking
like
about
breaking encryption,
breaking encryption,
disrupting critical infrastructure.
disrupting power grids,
Oh, wow.
communications networks,
Yeah.
financial systems,
Developing new kinds of weapons.
potentially, yeah.
Oh, that's scary.
I mean, it's something we need to be prepared for.
Yeah.
We need to start thinking now
Okay.
about the ethical implications.
Of quantum computing.
Yeah.
And develop safeguards.
To make sure
Okay.
that this technology
Yeah.
is used responsibly.
That's a tall order.
It is a tall order. I mean, how do you even begin to
Well,
at safeguards?
it's going to require a lot of collaboration
Okay.
between scientists,
Uh-huh.
policymakers,
Okay.
ethicists.
So like a global effort
Yeah, pretty much.
to make sure.
We need to have open and honest conversations about the potential impact
Okay.
of quantum computing on society
Yeah.
and make sure we're steering its development
In the right direction.
in a direction that benefits all of humanity.
That seems like
A big challenge.
a constant theme
It is.
throughout history.
Yeah.
Right.
We invent these incredible tools,
Mhm.
but then we have to grapple with the unintended consequences.
Right.
It's like we're always playing catch up.
We create the thing and then we're like, oh,
Yeah.
wait a minute.
We didn't think about
You
that.
didn't think about the ethical side of things.
It's true. But with quantum technology,
Yeah.
we have an opportunity to be more proactive.
Really?
Yeah.
How? So,
We can learn from past mistakes
okay.
and work to build ethical considerations
Into the technology itself.
into the very fabric of this new technology.
Okay. So instead of as an afterthought,
Exactly.
It's-
We need to bake it in
baked in from the beginning.
from the very beginning.
So we need to think about things like
We need to think about things like access
access,
and equity,
equity.
making sure that the benefits
Okay.
of quantum computing are shared widely
Okay.
and not just concentrated.
In the hands of a powerful few.
Exactly.
Okay. So assuming
Yeah.
we can navigate
Yeah.
these ethical challenges.
Hopefully we can.
Yeah.
It's going to be tough.
Yep.
But I think it's important.
Where do you see all of this heading
Okay, so
in the next decade or
you
two?
want me to gaze into my quantum crystal ball?
Yeah. What's your
Well,
quantum crystal ball telling you?
Well, it's hard to predict the future with certainty,
Of course.
but I think it's safe to say
Yeah.
that we can expect to see some truly remarkable advancements
In quantum technology.
in quantum technology
Okay.
in the coming years.
Like what?
Well, we'll likely see quantum computers becoming
yeah.
more powerful,
Okay.
more stable,
Right.
and more accessible
More accessible.
to researchers and developers
Okay.
around the world.
So are you thinking
I'm thinking,
along the lines of
yeah, cloud-based quantum computing platforms.
quantum computing? So
Yeah. Instead of needing to own
leading to
a massive,
Wait, go
expensive
ahead.
quantum computer,
right.
you could just rent processing time
Rent processing time
on a quantum cloud.
on a quantum cloud.
That's right.
That would be a game changer.
It would be a huge game changer.
In terms of making this technology available
Yeah.
to more people.
And wider range of people
Yeah.
and organizations.
Okay. And as the technology matures,
Yeah.
we may even see
We might even see
Yeah.
the first
commercial applications.
commercial application
Commercial application
of quantum computing.
in areas like what? Drug discovery,
Okay.
material science,
Uh-huh.
financial modeling.
So like
Imagine a world.
with quantum design drugs,
Quantum design drug.
ultra-efficient solar panels,
Ultra-efficient solar panels.
and self-optimizing investment portfolios.
Self-optimizing investment portfolios.
That sounds pretty good.
It sounds pretty amazing to me.
Yeah.
I'm excited to see what happens.
Yeah, so the potential is limitless,
It really is.
but out of all the possibilities,
Yeah.
what are you
What am I most excited about?
personally most excited
Yeah,
about?
it's a tough one.
Yeah.
There's so much to be excited about,
Yeah.
but I think the development of a true quantum internet
Okay.
is incredibly intriguing to me.
A true quantum internet.
Yeah.
Now, we touched on that earlier.
We did, but let's dive a little deeper.
Yeah, dive a little deeper.
Imagine a network.
Where information is transmitted instantly and securely
Okay.
using the principles of quantum mechanics.
That's wild.
It's pretty wild.
Yeah.
It could revolutionize communication,
Okay.
enabling unhackable communication channels,
Okay.
ultra-fast data transfer,
Uh-huh.
and even distributed quantum computing.
Hold on.
Yeah.
Distributed quantum computing. What does that mean?
So that means that multiple quantum computers
Uh-huh.
around the world
Okay.
could work together
Mm-hmm.
as one giant interconnected system
Oh, wow.
to solve complex problems
Okay.
that are currently beyond the reach.
So problems that even
Even the most powerful supercomputers
our best supercomputers today
can't even touch.
we can't even touch.
Yeah.
Wow. So this would unlock
It could unlock unprecedented computational power,
unprecedented
Yeah.
computational power.
allowing us to make breakthroughs
Okay.
in fields like medicine,
Mm.
climate change,
Oh.
and artificial intelligence.
So like literally
Changing the world.
solving humanity's biggest challenges.
Okay, this is...
Really talking about sci-fi stuff.
I know, it sounds like science fiction.
Yeah.
But it's based on real science.
Okay, but how realistic is this?
Good question.
Are we really talking about a quantum internet
In our lifetime.
in our lifetime?
Yeah, I believe it's more than just a pipe dream.
Really?
We're already seeing significant progress
Mm-hmm.
in teleporting quantum information
Okay.
over fiber optic cables
Okay.
and between satellites.
Wow.
So the technology is advancing rapidly.
Okay.
While there are still technical hurdles to overcome,
Sure.
I think a basic quantum internet
Uh-huh.
could become a reality
Really?
within the next decade or two.
Wow.
Of course,
Yeah.
building a full-fledged
Right.
global quantum internet
Yeah.
will require significant investment
Okay.
and international collaboration.
That makes sense.
But the potential rewards
Yeah.
are enormous.
Yeah, it's mind-boggling
It is.
to think about the possibilities.
It really is.
But it also raises a lot of questions.
It does.
If we can create a truly unhackable internet,
Yeah.
what does that mean
What does that mean for privacy?
for privacy?
Right.
Could it be used?
Used to suppress dissent
Oh, wow.
or shield illegal activities.
Yeah.
These are questions we need to think about.
And what about the impact on jobs
Oh, right.
and the economy?
And economic implications are huge.
Yeah.
If quantum computers can automate
Yeah.
tasks that are currently done by humans,
Right.
what will happen to the workforce?
That's a big question.
That's a huge question.
Yeah.
These are all important questions
Yeah.
that we need to grapple with
As we move forward.
as we move forward.
Yeah.
Technology is a tool.
Okay.
And like any tool, it can be used for good or for evil.
That's a good point.
The development of a quantum internet,
Yeah.
with its immense potential for good,
Uh-huh.
also brings the potential for misuse.
Right.
It's our responsibility
To make sure it's used for good.
to anticipate those potential pitfalls
Okay.
and to build safeguards into the system
Yeah.
from the very beginning.
So it sounds like
It does.
we're entering uncharted territory.
We are.
And there's no roadmap
There's no roadmap
for how to navigate
for how to navigate this,
the ethical,
the ethical and
the
societal implications of this technology.
the implications of this technology.
It's a new frontier,
Yeah.
and we're going to have to figure it out as we go.
So before we move on to our final segment,
Okay.
I want to make sure I'm understanding the key takeaway
Okay, shoot.
from this part of our conversation.
Right.
Are you saying that while the potential benefits
Yes.
of quantum technology
The potential benefits are enormous.
are enormous,
Yeah.
we also need to be mindful?
We need to be mindful of the potential risks. The potential risks.
Yeah.
And start thinking now
And start thinking now
about how to mitigate those risks
about how to mitigate those risks.
to create summary.
It's about finding the right balance
Okay.
between fostering innovation
Yeah.
and protecting our values.
Fostering innovation and protecting our values.
That's the key.
All right, so we've talked about
We have
the technical breakthroughs,
we've talked about the breakthroughs,
the potential benefit,
the potential benefits,
and the ethical challenge.
yeah, and the ethical challenges.
Now,
Sure.
in our final segment,
Okay.
I want to dive into some of the even more mind-bending implications
All right, let's get really philosophical.
of a quantum future.
Okay.
If quantum mechanics challenges our understanding of reality
Which it does.
at a fundamental level,
At a fundamental level.
what does that mean?
What does that mean?
For our understanding of consciousness,
Consciousness.
free will,
Free will.
and the nature of the universe itself.
The big question. Welcome back to the deep dive.
We're in the deep end now.
We're in the deep end.
Yeah.
We've been exploring
The deepest part of the pool.
this incredible world of quantum teleportation.
It's a wild world down here.
And now
Yeah.
we're going to take things even further.
Okay.
We've talked about the
Awkward.
technology,
The nuts and bolts.
the potential benefits,
The amazing possibility.
the ethical
It's
considerations.
the questions.
But now I want to get into some of the even bigger,
Okay.
more philosophical questions
Yeah.
that this research raises.
The really juicy stuff.
All right, so quantum mechanics.
Quantum mechanics is a trip.
It challenges our understanding of reality
It really does.
at a fundamental level.
It's like it's turning everything we thought we knew upside down.
Okay, so how deep does this rabbit hole go?
Well, let's start with this idea
Okay.
of a quantum internet
Yeah.
being unhackable.
Right, that was a big part of the research.
If we can really create a network where information is transmitted
Uh-huh.
in a way that's fundamentally secure,
Okay,
what does that mean for privacy?
that's a good question.
Could it lead to a world where secrets are impossible to keep,
Oh, wow.
or one where absolute privacy is guaranteed?
So it's like two extremes.
Like we're either completely transparent
Yeah,
or completely shielded.
it's like,
And it's hard to know which way it'll go.
yeah, which is more dangerous.
Right, exactly.
That's a good question.
And it makes you wonder about the potential societal impact.
Yeah, like how would that change things?
Could it disrupt power structures,
Okay.
change how we interact with each other,
Uh-huh.
even alter our understanding of trust and identity?
That's like a whole,
It's like a whole new way of being.
yeah, a whole new world.
It goes even deeper than that.
Okay, deeper than that.
So if quantum computers can simulate the universe
Oh, wow.
at a fundamental level,
Okay.
as some physicists believe,
Okay.
could we eventually reach a point
Yeah.
where we're creating simulated realities?
Simulated realities.
Like in the Matrix.
Like we're living in a simulation.
Yeah, that's a possibility.
That's crazy.
It is crazy.
But it's also kind of cool.
It's kind of cool.
Yeah.
Would those simulated realities
Yeah.
be any less real
Oh, that's a good question.
than our own?
I mean, if you're experiencing it, right, doesn't matter.
If you can't tell the
You
difference,
can't tell the difference.
does it matter if it's real or not?
That's deep.
That is deep.
So if consciousness is ultimately just information,
Oh, okay.
as some theories suggest,
Yeah.
could it be transferred
Could we download our consciousness
or even duplicated
into a computer? like copy and paste?
Yeah, like copy and paste your soul.
Wow. Would our digital copies?
Would they be considered separate individuals
Oh, that's a good question.
or extensions of ourselves?
Like, would they be us?
Would they have their own rights?
Or would they just be like
Their own
a
experiences.
copy
These are questions.
that have puzzled philosophers
I bet.
for centuries?
Yeah.
But quantum technology,
Brings them in a whole new light.
it does.
It really does.
It forces us to re-examine our assumptions
About.
about what it means to be human,
Yeah, okay.
what constitutes reality,
Yeah.
and what
yeah.
the limits of knowledge truly are.
I feel like I need to go lie down after this.
It's a lot to process.
This deep dive has really taken us on a journey.
We've gone deep.
It's gone way beyond just learning about a scientific discovery.
It's about the big picture.
It's making me question everything.
That's the point.
I thought I knew about the world.
It's about challenging our assumptions,
Yeah.
expanding our minds.
So, as we wrap up
Okay.
this deep dive,
Look at the surface.
we're at the surface
Yeah.
into quantum teleportation
It's been a wild ride.
and all its mind-boggling implications.
I know, right?
What's the one thing you hope
What do I hope our listeners take away?
our listeners
Yeah.
take away from this conversation?
I hope they come away
Yeah.
with a sense of wonder
Wonder.
and possibility.
Possibility.
We're living in an extraordinary time,
We are.
a time of unprecedented
Uh-huh.
scientific and technological advancement.
It's pretty amazing.
Quantum technology, in particular,
Yeah.
has the potential to fundamentally reshape our world.
In ways we can only begin to imagine.
It's like we're on the cusp of something truly transformative.
And as we navigate this uncharted territory,
Yeah.
it's crucial to approach it.
With both curiosity
Curiosity.
and responsibility.
Responsibility.
We need to be excited about the possibilities,
Yeah.
but also mindful of the potential risks.
We can't just blindly rush in.
No, we need to think carefully
Yeah.
about the choices we make.
About how this technology
Because those choices
shape
will
it
shape the future.
for generations to come.
Absolutely. So to our listeners
Yeah.
who are now as fascinated
I hope so.
by this topic as we are,
It's contagious, isn't it? Keep exploring.
keep asking questions.
And never lose your sense of wonder.
The world is full of mysteries,
The quantum realm is full of mysteries.
waiting to be uncovered.
Waiting to be uncovered.
Who knows?
Yeah.
Maybe one of you listening
Yeah.
will be the one to make the next groundbreaking discovery.
That pushes the boundaries
That changes everything.
of human understanding even further.
It could happen.
That's an inspiring thought.
It is.
And on that note of possibility,
Yeah.
we'll wrap up this deep dive
Back to the shallow end
back to the shallow end
for now.
into quantum teleportation.
Until next time.
Thanks for joining us
It's been a pleasure.
on this incredible journey.
Keep exploring.
Until next time,
Stay curious.
keep exploring the frontiers of knowledge.